Saya duk loading lagi ni. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Okay, students of Tamhidi, welcome to our live session of organic workshop. Actually, introduction to organic. Okay, IUPAC Nomenclature. Okay, alhamdulillah rabbil alamin wassalatu wassalam ala rasulillahi ajmain. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbana atina fid dunya hasanah fil akhirati hasanah wa qina azabannar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi walhamdulillahi rabbil alamin. Okay, so as you know, okay, actually we plan to do the workshop last week, but there's a technical problem. So we have to do this week also, because since most of you already entered chapter 4. Okay, so the talk will be given by Madam Latipah Mohd Noor. Okay, so without further ado, so I will let Madam Latipah to give her talk about chemistry, IUPAC Nomenclature. Okay, I will send this live. Madam Latipah, send live. Okay, slide. Okay, Madam Latipah, I will mute my mic after you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, how are you? Students of Tamhidi Center for program Tamhidi of Medicine, Dentistry and Science. Okay, and Tamhidi Science, Technology and Science, Physical and Technology. Okay, welcome to our pre-organic chemistry workshop. Okay, for 2020 semester 2. Okay, for session 2021-2022. Okay, so this workshop objective is to teach you, okay, to learn, okay, about how to name the organic compounds, okay, organic compounds using IUPAC Nomenclature, IUPAC, okay, which is used worldwide. Okay, so let's start the discussion now. Okay, you may refer to your course book. Okay, in page, okay, starting in page 135. Okay, starting in page 135. Okay, all right. So hopefully you can see my slide clearly. Okay, introduction to organic chemistry. So this is in chapter 4. Okay, focus on IUPAC nomenclature of organic compounds. Okay, so what is IUPAC? Okay, so the purpose of this of the IUPAC system of nomenclature is to establish an international standard of naming compounds to facilitate communication. Okay, so every chemist in this world, okay, will use the same way, okay, the same method to give name to the organic compounds. Okay, and it also gives us give each structure a unique and unambiguous name. Okay, to correlate each name with a unique and unambiguous structure. Okay. So what are the fundamental principle of IUPAC nomenclature? Okay, it is based on naming of a molecule along the chain of carbons, okay, connected by single bonds, whether in a continuous chain or in a ring. Okay, so we will have to count the longest carbon chain, okay, if it is in a straight chain or with branch or with compound with rings. Okay. So all the deviations, okay, either multiple bonds or atoms other than carbon and hydrogen are indicated by prefix or suffix according to specific set of priorities. So we have a table of group A, group B, group C. Okay, you can see in your book. Okay, so we will see what is prefix, what are prefix, what are suffix. Okay, so prefix, okay, when functional group becomes substituent. A suffix is when the functional group becomes parent. Okay, so parent here is the main chain, okay, of the organic compounds that we are going to give name. Okay, So we will start with alkane and cycloalkenes. Okay. So alkenes, okay, they are family of saturated hydrocarbon. Okay, saturated hydrocarbon. Okay. I use my pen here. Okay, saturated hydrocarbon, meaning it consists only single bond. Okay, C single bond C. Okay, and containing carbon and hydrogen. Okay. So these molecules can be in continuous chains. They call linear or acyclic. Linear means maybe it is straight chain or maybe it is uh, with branch. Acyclic is another term for it. Or with rings. Ring meaning we usually call it as cyclic or alicyclic. So make sure you know this term. Okay, so the names of alkenes and cycloalkenes are the root name of organic compounds. Okay, usually we will just change the names at the end of the parent chain based on the functional group exists in that compound. Okay, so beginning with the 5-carbon alkene, the number of carbons in the chain indicated by Greek or Latin prefix. So the rings are designated by prefix cyclo. Cyclo means we have ring in the structure. So maybe this one no need to be explained. Okay, so let's go to the next slide. The first 10 unbranched alkene. So this is actually the basic naming for all organic compounds. So if we have one carbon, we call it met. So if it is alkene, we call it methane. Met for one carbon, at for 2 carbons, prop for 3 carbons, but for 10, 5, hex, 6, hep, 7, oct, is 8, non, 9, and that is 10. So usually in our syllabus, we will just ask you until maybe maximum 10 carbons in the structure. So please remember, met, at, prop, boot, pen, hex, hep, oct, non, that. Alright. Now let's go to some cycloalkenes. So what are the cycloalkenes that we can have here? They are cyclopropane. Cyclopropane with 3 carbons. 4 carbons, we have cyclobutane. 5 carbons. 5 carbons, we call it as cyclopentane. 6 carbon is cyclohexane. If it is 7, cycloheptane. If it is 8, cyclooctane. Alright. Now let's proceed to the nomenclature of molecules containing substituents and functional groups. Substituents and functional group. What are substituents? Substituent means kumpulan penukar ganti. Substituent. So priorities of substituents and functional groups. So we have, as I said just now, we have some tables of the groups of functional groups. For example, group E, functional group indicated by prefix or suffix. So we have carboxylic acid. I'm sure you know this because this is also part of syllabus in SPM level. Carboxylic acid. So the structure has COOH. So it is not given in the slide, so I have to draw C double bond OOH. Aldehyde. Aldehyde is has the second priority. So we have C double bond OH. And then ketone, the third priority, C double bond O R. So what is R? R here is alkyl group. Alkyl group. Maybe you are not familiar yet with this. So we will discuss further about what is R in the organic compound structure. And then alcohol. Alcohol we have OH and amine. Amine we have NH2. Alright. So if the carboxylic acid becomes the prefix, we meaning it becomes the substituent okay, we have to name it as carboxy. Okay, and if it becomes the parent chain, okay, it will be oic acid. Okay, oic acid. Okay, aldehyde, okay, we have to name it as oxo. Okay, same with the name for prefix of ketone if they become the substituent. Okay, but okay, if let's say in the structure we have aldehyde, we also have ketone and both become the substituent. Okay, one of it, which is aldehyde, we will call it as formyl. Okay, we will see a lot of example after this. Okay, and if it becomes the parent chain, okay, it will be uh, okay, carbaldehyde, okay, or pentanol, for example. Okay, so it will be at the end of the name. Okay, and then alcohol, okay, we usually call it as hydroxy when it becomes the substituent. Okay, and if it is a suffix, we call it as pentanol, hexanol, all, okay, at the end of the parent chain name. Okay, for amine, we call it as amino, and then the suffix we call it as amine. Okay, so if it become the parent chain, we call it as amine. Okay, cyclopropane, okay, for example. Okay, so if it becomes the substituent, we call it as amino. Alright. Hopefully, I'm not too fast. Okay, so let's go to the next group, group B. Okay, so you need to understand this in order to give name, okay, to the organic compounds. Okay, so for group B, alkene. Okay, what is the structure? Okay, we will have C double bond C. Okay, oh sorry, it should be two branch there. Okay, because we must have carbon must have 4 bonds at one time. Okay, so this structure must have like this. Okay, so it can be bonded to H or it can also be bonded to R, alkyl groups. So alkyl groups is actually the CH3, CH2, CH3, okay, CH2, CH2, CH3. I will show you the table for the alkyl groups, okay, after this. Right, for alkyne, okay, it has C triple bond C. Okay, but in for alkyne usually will not ask you because it has been eliminated from our syllabus. Okay. The next group C is substituents. Okay, indicated by prefix. Okay, only by prefix. So it can only be the substituent. Okay, so alkyl groups. Okay, structure. Oops. The structure of alkyl groups usually we represent it with R. Okay, R is the symbol for alkyl groups, okay, general alkyl groups. So as I said just now, it can be methyl, ethyl, propyl, okay, cyclobutyl, cyclopentyl. So that will be the alkyl groups, okay. And they will only be the substituent if they are not the parent chain, okay. Alkoxy is OH3, okay. And for halogen, depends on the symbol here, depends on the we can maybe I'm quite fast to click my slide. Okay, so let's go to this one. Okay, so night. Have C double bond C. Okay, so this one C, but this carbon has one H. Okay, let me redraw this. it will become the substituent. And then for allele, for allele, it means we have 3 carbons, still double bond, but now we have this structure. CH double bond, next slide. So another structure is called benzene. Benzene. You can see in your book. Benzene. What is the difference with benzene? The benzene ring together with the CH2 becomes the substituent. Right? Okay. So let's move to the next one. Okay, some alkyl groups are substituent. Okay. So for this one, if we have 1 carbon, it is methyl. 2 carbons, ethyl. 3 carbons, we call it as propyl. So how to draw isopropyl? Isopropyl. It means we have 3 carbons. Met 1 carbon, et is 2 carbons, prop is 3 carbons. And then isopropyl, prop is 3 carbons. But the structure, if you refer to your book, the given structure has 3 carbons. But how to remember? How to remember isopropyl? So isopropyl, parent, it is bonded to the substituent. So the substituent that has isopropyl, that is isopropyl, will have 3 carbons like this. For example, we complete the structure, so it becomes like this. So how to remember this shape? Remember V shape. So the isopropyl structure is like V. Now let's move to this one, butyl. But 4 carbons, but just a straight butyl structure. Straight chain. Isobutyl, like this. Isobutyl is like this. We have 1, 2, 3, 4 carbons. It is isobutyl. It's different with sec butyl. Sec butyl, very easy to remember. We have the parent chain. Parent chain. It is bonded to the second carbon in the substituent. This is 1, 2, 3, 4. So this is the second carbon. It is bonded to and we can draw the so what I'm showing you here is how to remember the shape. To give name is the shapes. Sorry, if the structure. Isopentyl. chain, we will have 5 carbons. Okay, so the Y shape will be longer. Okay, 1, 2, 3, or maybe not enough space there. Okay, I will redraw. Okay, the Y is longer. Neopentyl, very easy to remember. Parent chain, bonded to 5 carbons. And the shape of neopentyl is like this. So it is like small. The name for the substituent for alkyl group. All right. So if we have cyclopropyl, so we just draw 3 triangle shape. Okay, triangle shape, cyclopropyl, cyclobutyl, cyclopentyl, and this is benzene. Okay, so just now okay, steps. Okay, basically, we have to find the longest continuous carbon chain, okay, to give the to serve as the root name for the parent chain. Okay, if it is cyclic, still have to count the number of carbons in the cyclic structure. Okay, if it has so maybe step 5. Okay, in step 5, okay, in alphabetizing, okay, before that, okay, when you want to give name, okay, after you give number to the carbons, okay, the naming will follow alphabetical order. Okay, alphabetical order meaning is if we have iso and cyclo, okay, you have to consider the I for iso and C for cyclo. Okay, so always include a position number for each substituent regardless the redundancies. All right, let's see the example. Okay, first example, practice. Substituent. Okay, so let's start naming. Okay, what is the longest carbon chain? If we count from left, okay, if we count from left, we will have so our parent chain name will be, okay, it will be octane. Okay, because 8 carbons, so the parent chain name will be octane. Okay, so next what we have to do, okay, check what are the substituents that we have in our structure. So we have, right here we have chloro, okay, we have Br, and this one is the substituent called ethyl. Okay, so how to give name? Follow alphabetical order. Okay, follow alphabetical order. So we will start with BR. Okay, because B before C. Okay, after that, after C, we will have MOE. Of course, it is E. Okay, after that, M. Okay, so that number we put dash again. Okay, 3 bromo. Okay, next is chloro, 2 chloro. Okay, then continue. We have ethyl dash. Okay, 5 ethyl. Okay, and then we have, so it will become dimethyl. Okay, dimethyl. So the number for the dimethyl, it is bonded to carbon number 4. So it will be 4 for the first methyl. Let's say this one. Okay, for the second methyl, we put the position also 4. Okay, so that's not, there's no enough space there. Okay, so I will release the octane name. Okay, to continue naming. Alright. Here for the, okay, let's rewrite. Methyl octane. No space between methyl, dimethyl, and octane. Okay, between the substituent and the parent name, there will be no space. Okay, so make sure, okay, when we have number after number, we put comma. Okay, when after number, we have word. So that I can check the quality of my voice.
Okay, students, we have some internet difficulties, technical. Okay, let's take a break while we try to solve this problem. Guys, if you have any question, you may try to ask in Q&A. Okay, Q&A.
Korang dengar tak? Okay.
Sekejap ya. Still lagging, Latipah. Still lagging. I'm not sure whether my internet problem or Latipah problem.
I think Latipah internet kot.
Okay, can you hear me?
Yes.
Boleh dengar ke?
Yes, Latipah.
Huh? Dengar tak?
Yes. We can hear you.
Dengar tak?
Yes.
Okay.
Okay.
Dengar ya?
Okay,
I think
clear.
my Bluetooth device has problem. So, okay, clear eh? Okay, so
Okay,
maybe we
clear.
can continue. Boleh eh? Okay, are we live now? Okay, terus ya? Okay, so let's continue. Okay, with the next example. Okay, this is fine. Okay, now let's give the name to this compound. Okay, so this is the second compound. Okay, in page 140, practice 4.9. Okay, so how to give name? Okay, as usual, we count the longest carbon chain. Okay, just the same step as in the previous example. Okay, so we give a number to the longest carbon chain. Okay, so where to start? Okay, whether we start from left or from right. Okay, so if we start from left, it will be 1, 2, 3, 4, 5, 6. Okay, that one if we start from left. Okay, but we also have the carbon chain above. Okay, so we have to include that. Okay, so if we start from right, okay, we can have, let's say I give I write with different color of pen. Okay, so we will have 1, 2, 3, 4, 5, 6, and 7 carbon. Okay, so 7 carbons, okay, longer than 6 carbon. Okay, so if we count from left 1, 2, 3, 4, 5, 6 till 6 carbon if we count from left. Okay, if we go upward. Okay, so we will use the numbering which is in the blue color. Okay, so I will erase this one. Okay, so this is carbon number 1, number 2, number 3, 4, 5, 6, 7. Okay, so what are the substituents that we have? Okay, we have 1, 2, okay, and these are not included in our parent chain. Okay, so we have 3 substituents. So this one is called methyl, and this one is called fluoro. Okay, fluoro, and this is like V shape. Okay, bentuk macam V. So we can name it as isopropyl. Okay, isopropyl. Okay, so how to give name? Okay, we follow alphabetical order. The parent chain will be heptane. Okay, parent chain will be heptane. So the name is 3-fluoro. Okay, 3-fluoro. Okay, and then we have 4. Okay, I is included in the naming. 4 isopropyl. Okay, and then methyl is at carbon number 2. 2 methyl. Okay, 7 carbons. Heptane. Okay, so this is the name of compound number 2. Now let's go to compound number 3 in page 141. Okay, 141. Okay, so what is the longest carbon chain? If we count, sorry. Okay, if we count the number of carbon, okay, from here, from left or from right, okay, we will have 1, 2, 3, 4. Okay, 4 carbons in the chain. Okay, so this will not become the parent chain. Okay, so we will take the parent chain as the carbons in the cyclic. Okay, so we'll have 1, 2, 3, 4, 5, 6 carbon in the ring. Okay, so that will be the parent chain because the number of carbon in the ring is larger than the number of carbon outside the ring. Okay, so why not we start from nitro and O2? Nitro, this is nitro. Okay, because this one, okay, we can call it as sec-butyl. Okay, so in sec-butyl, S is not included in the alphabetical order. Okay, we will take only B. So B will be the first substituent. Okay, so what will be the name of this compound? Okay, so it will be 1 sec-butyl and 1 sec-butyl, 3 nitro, is cyclohexane. Okay, so this is the name for compound number 3. Right? Let's proceed to this one. Okay, so the next example, we have a lot of carbon here. Okay, a lot of carbons. Okay, so let's count the longest carbon chain. Okay, longest carbon chain. Okay. Okay, where to start the numbering? Okay, let's say we start from left. okay, because Rumi start from left. Okay, we read Rumi from left. Okay, let's start from left. Okay, so let's say we have 1, 2, 3, 4. Where to go? Downward or to the right? Okay, let's say we go to the right. 4, 5, 6, 7. Okay, we have 7 carbons there. Okay, if we go downward, we will have 4, 5, 6, 7. Also 7 carbons. Okay, so which one that you should choose? Okay, so if we have the case like this, structure like this, okay, so what you have to do is to choose the number, the parent chain that will give you a lot of substituent in the naming. Okay, so actually, okay, we have to start the numbering from right. Okay, why from right? Okay, I will rewrite using different color now. Okay, so refer to the red one. Okay, the numbering should start from here. 1, 2, 3, 4. Okay, 5, 6, 7. Okay, so next we have, okay, we can go downward. Okay, it will be 5, 6, 7. Okay, why we start from right? Because we want the substituent. Okay, the nearest substituent to get the lowest number of carbon. Okay, the nearest substituent that we have here is the CH3 here. Okay, so we will have to use the red one. But which one? Is it the straight one? Okay, or the one go down, okay, to the 7 CH3. Okay, CH3 number 7. Okay, the answer is, okay, we have to choose the carbon chain which will give you the greatest number of substituent, okay, which is count to the left. Okay, so I will erase this one. So we have to count to the left, okay, to give us a lot of substituent. So I will use the numbering with red color. Okay, so how to give name to this? Okay, so what are the substituents that we have? We have 1, 2, methyl. This is 3 carbons. Okay, these are methyl. This is also methyl. This is propyl. And this one is methyl. Okay, so the name will be, okay, the parent chain is heptane. The name will be, let's give the name. Okay, so which one should go first? Okay, is it P or M? Okay, it should be M, right? Okay, it should be M. So we have 3 methyl here. Okay, 3 methyl structure. So the name will be tri. Okay, so 2, 3, 5. Okay, there are 5 carbons. Okay, 2, 3, and 5. Okay, trimethyl. Okay, 3 carbons that hold the methyl. Okay, and then we have propyl at carbon number 4. 4 propyl. Okay, 4 propyl. And the parent chain name is heptane. Okay, so this is the name for this structure. Okay, why not we give name because we have 7 carbons. Okay, if we write it, if we count it from right straight, okay, we have 7 carbons. Okay, if we count it from right, 1, 2, 3, and we go down. Okay, 1, 2, 1, 2, 3. Okay, 4, 5, 6, 7. We still have 7 carbons. It can be the parent chain too. But why not this one becomes the parent? Okay, the reason. Okay, let's give name with this blue black numbering. Okay, what will be the name? Okay, we will have the substituent at carbon number 2 methyl. Carbon number 3 is methyl. Okay, carbon number 4 will have this shape. Okay, this is, what is this? Okay, we have 1, 2, 3, 4. It's side butyl. Okay, we have side butyl there. So if we use the blue-black numbering, we will have the name 2, 3, 4. Is this correct? 1, 2, 3. I silap. Okay, it's not like that. Okay, we will have methyl at carbon number 2 and carbon number 3. Okay, let's give the name. And methyl at carbon number 2 and carbon number 3. 2, 3 dimethyl. Okay, 2, 3 dimethyl. And then 4, 2, 3 dimethyl, 4 sec-butyl. Oh, it should be sec-butyl first, right? Okay, sec-butyl first because sec is not include, butyl include. Okay, let's rewrite the name. Okay, so it should be 4 sec-butyl. Okay, sec is not included in the alphabetical order. We just take B. 4 sec-butyl. Okay, and then 2, 3 dimethyl. Di is not included. D for di is not included, but methyl M is included. Okay, methyl, okay, heptane. Okay, why this one is wrong? Okay, we can still get the same number of carbon for the parent chain, 7 carbons. Okay, but why the name written with the blue-black pen is wrong? Okay, because right here we have only 1, 2, 3 substituents. Okay, what are the substituents? The methyls, okay, and the sec-butyl. Okay, but if we count the number of carbon, the parent chain straight, okay, from right to left, okay, we will have 7 carbons also, but we will have the circle substituents 1, 2, 3, 4 substituents. So 4 substituents, greater number of substituents is better. Okay, lagi banyak anak lagi bagus. Okay, so remember that. Okay, the greater the number of substituents, okay, that will become the name that we will choose, okay, for the compound. Okay, so hopefully you can understand this. Okay, why we choose the red one as the naming for this example. Okay, so Safi, is there any question that students want to ask? Or maybe I can just continue.
Questions. I cannot see any questions. Not sure.
So far no question.
Loading.
Okay.
Not sure.
Okay, students.
Dr. Jannah or Madam Ruby.
This is session.
Okay. Oh, not this.
Okay.
Aduh, yang ni yang terlepas lah. Ada soalan yang tanya kalau bromo instead of fluoro. Some request, Latipah.
What is the question, Safi?
Naming
Yes.
boleh ulang tak untuk naming substituted alkenes?
Substituted alkenes, which one?
Which one
Substituted alkenes. Which part?
Methyl, I think so.
We are still discussing substituted alkenes actually.
Actually we still discussing
still under alkene. We haven't proceed to the other functional steps. Okay. Right. Maybe the students can repeat the video later. Can we continue? Okay, Safi?
Okay. You can continue.
Yeah. Alright. Let's go. Naming molecules containing functional groups from group B, but suffix only. Okay, so prefix and suffix Okay, make sure you understand that one. Okay, for alkenes, okay, follow the same step as for alkenes, except okay, the number the chain of carbon that includes C double bond C, okay, so that C double bond C has the lower position number. Okay, so C double bond C must have the lowest number of carbon. Okay, that's the same. Okay, so when you put the numbering, okay, when you write the numbering for the carbons, okay, make sure the C double bond C has the lowest number of carbon. Okay, we change in to in and assign a position number to the first carbon of C double bond C. Design geometrical isomers with a cis trans prefix. If we have cis structure, okay, I'm sure some of students, some of classes has discussed, okay, has already discussed about cis trans isomerism. We'll see how to give name to cis trans isomerism. Okay, so when two identical groups are attached on the same side of double bond, okay, the compound is called cis. Okay, for example, okay, we have C double bond C. Okay, and let's say we have H. This one, let's say CH3. Okay, so this is what we consider as same side. Okay, so we call this as cis same side. Okay, cis same side. Now remember that. Cis same side. Okay, how to remember trans? Okay, trans. Okay, let's say we have this structure. Okay, we have H, we have H here, we have CH3 and CH3. And this one, H is opposite side. CH3 also on opposite side. Okay, opposite side. Trans tentang. Bertentangan. Okay, T for bertentangan. Okay, trans bertentangan. Okay, trans opposite side. Okay, so remember that. Right. Let's try to give name to this. Okay, so we have a lot of carbons here. Okay, how to give name? And make sure the C double bond C has the lowest number of carbons. Okay, so where to start? Is it from left or from right? Okay, if we start left, okay, the numbering, let's put the number 1, 2, 3, 4, 5, 6, 7, 8. Okay, but if we start from the right, okay, let's see what is the difference. Okay, if we start from the right, the numbering will be 1, 2, 3, 4, 5, 6, 7, 8. Still the same. 8 carbons. Okay, but why the red one is wrong? Okay, because right here we can see if we start from left, the C double bond C, the first carbon of C double bond C will have carbon number 3. Okay, but if we start from right, okay, the first carbon of the C double bond C will have carbon number 5. So that will be wrong. Okay, so the red numbering is wrong. We have to start from left. So it depends on the structure. Okay, not necessarily to start from left and only. It can also start from right. It can also start from upward or from up, or from above or from below. Okay, so we will start, we will give naming based on the numbering starts from left. Okay, so the C double bond C is at carbon number 3. So the name is 3-octene. Why octene? Oct is 8 carbons. Okay, in is for alkene. Okay, 3-octene. Or another way to write it, okay, is oct. Okay, oct. Okay, we put the parent chain name, 8 carbons, oct, 3 in. Okay, so we have two ways to name the compounds. Okay, whether we name it as 3-octene or oct3in. Okay, let's go to the next one. Okay, when we have structure like this, some of you may be not familiar with the condensed structure yet, okay, because you are beginners. Okay, so I suggest you to redraw the structure. Okay, open up the structure a little bit. Okay, CH32 it means we have two CH3. One of the CH3 will be the substituent. So this is another way to draw the structure. Okay, so refer to the one that I draw using the blue-black pen. Okay, let's give, okay, still the same method. You have to give number and make sure that the C double bond C and the substituent, okay, now we have substituent, they must have the lowest number of carbon. So if we start from left, we will have 1, 2, 3, 4 carbons. Okay, if we start from right, okay, let me change the color of the pen. Let's say the green one. Okay, if we start from right, we will have 1, 2, 3, and 4. Okay, so which one should we choose? Is it the red one or the green one? Okay, as I said just now, make sure the numbering for the C double bond C and the substituent is the lowest. So if we choose the red one, okay, carbon C double bond C, the first carbon of C double bond C will have carbon number 2. Substituent methyl here will also have carbon number 2. Okay, but if we choose the numbering, which is the green one, okay, the substituent and the C double bond C will have numbering number 3. So we will not choose that one because 2 is smaller than 3. Okay, so the numbering will start using the red one. Okay, let's give the naming. Let's give the name. Alright. So bond there. So we have 2 double bond at carbon number 2, methyl at carbon number 2. So how to give name? Okay, we start by giving the name of the substituent. So the substituent that we have here is methyl. So it will be 2-methyl. Okay, 2-methyl dash 2. Okay, position of the double bond, butene. 4 carbons. Okay, 2-methyl, 2-butene. Another way to give name is 2-methyl butene. Up to you, which one that you want to choose. Okay, it's up to you. So for the next example, maybe you can do it by yourself. Okay, what if we have 2 double bonds in the structure? Okay, 2 double bonds. Okay, let's give the numbering. Okay, if we start from left, it will be the same if we start from right. So let's give numbering 1, 2, 3, 4. No substituent here. Okay, so we have double bond at carbon number 1 and carbon number 3. Okay, so how to give name? Okay, so the name will be, okay, we have 4 carbons. 1, 3. Okay, 1, 3 is the position of the double bond. And 1, 3. Butadiene. Kita guna ni kan, Safif? Am I correct?
Okay. Yes, butadiene.
Tapi tak ada ni lah.
Yes,
Okay.
butadiene.
Right? Okay. Right? Okay.
Wood.
Or you can give it as wood. Maybe this one is better. Wood 1, 3 diene.
Yes.
Hopefully nobody dying here. Okay. Hopefully nobody dying. Diene. Okay. Okay. So diene, not dying. Okay. Diene. Alright. So di here means 2. Okay. We have 2 double bonds in the structure. So we give it as the name as diene. Okay. If we have 3. 1, 2, 3, 2, 3, 4, 5, 6, 7. Okay, how to give name? What is the position of the double bond? 1, 3, 5. 1, 3, and comma 5. Okay, so let's say we use the second method to for naming. Okay, so we have 7 carbon. Hep. Hep. Okay, hep 7. 135, try in. Everybody are trying to understand. Okay, try in. Okay. What if we have cyclic? Okay, example number 6. Okay, what is this? Maybe some familiar with the skeletal structure. So this is the CH2, CH3. Okay, so CH2, CH3 name is ethyl. I do not have to refer to books anymore, but maybe some of you are not familiar with the structure, so you will have to refer to the book. Okay, so you can refer to the naming of the some common alkyl groups as substituent in page 139. Okay, in your course book. Okay, so what will be the parent? Okay, this will be carbon number 1. Okay, so when you have double bond in the ring, okay, make sure when you give numbering, okay, the number must be what we call it. It must be go through the double bond. Meaning we have carbon number 1 here. This must be carbon number 2. Okay, it cannot be carbon number 5. Okay, it cannot be carbon number. Okay, so this is the numbering for 5. Okay, and if we give numbering like this, okay, let's say we give the numbering 1, 2, 3, 4, 5. Okay, it is wrong. Okay, it will be wrong. So the red one is wrong because you do not go through the double bond. Okay, so you have to go through the double bond. Okay, to when you give the number to the cyclic. Okay, kat sini nak hujan. Okay, so maybe it will affect the quality of the internet. Hopefully not. Okay, let's finish this. Okay, so we will not use the red numbering. Okay, so I will erase this one. So let's give the name. Okay, what will be the name? We have ethyl at carbon number 1, so the name is ethyl cyclopropane. Okay, no need to give number to the let's say ethyl cyclo-1-pentene. No. Okay, it's not like that. If we have cyclopentene, just name it as cyclopentene. No numbering, no need to put the numbering for the double bond in the ring. Okay, so this is another example for it. Let's proceed. Maybe you can try to name number 7 later. So let's go to number 8. Okay, this is one of the example of cis trans. Okay, how to give name to cis trans. Okay, so this is cis. This is cis structure. Cl. Okay, they are both at the same side of the compound. Okay, so to name, we have 2 carbons only, 1, 2. Okay, so we put cis in front of the name, cis dash 1, 2. Okay, we have chloro here. Chloro. 1, 2, 2 chloro. So we call it as dichloro. 1, 2 dichloro ethane. Okay, so cis in front, dash 1, 2 dichloro ethane. Okay, and then for this one, Cl and Cl, they are at different side, opposite side. Okay, so this is trans. So to name it, we put trans 1, 2 dichloro ethane. Okay, so the naming is just the same as cis, okay, but we changed cis to trans because the position of Cl, okay, they are opposite one another. Okay, let's proceed. Okay, we have only half an hour to finish this. Okay, so naming molecules containing functional groups from group A, prefix or suffix. So maybe I will not discuss all examples, okay, because of limited time. Okay, maybe later you can discuss with your tutorial instructor in your tutorial group. Alright. So in naming molecules containing one or more of functional groups in group A, the group of highest priority is indicated by suffix. Okay, the other are indicated by prefix with priority equivalent to any other substituent. Okay, so suffix means it will become the parent name. Okay, the parent name. Namanya di belakang. Okay, but prefix, they will become the substituent. Okay, so the name will be in front. Alright? So remember, prefix is when the functional group becomes substituent. Suffix when the functional group becomes parent. Okay, as I explained just now. Okay, so we have modified set of steps for naming organic compounds. Okay, but I will not discuss further about this. You can read in your book. Let's go to this example. Amines. Okay, so this one is in page 143. Okay, example 4.11. Okay, so how to give name? Okay, you have to identify which one is the parent chain. Okay, which one is the parent functional group. Okay, so let's say we do the first one. We have NH2, and these structures are four structures are actually under amine. So we can just predict that the amine will be the parent. Okay, so we have amine here, NH2. It will become the parent. So numbering will start from here. 1, 2, 3. Okay, so parent chain, the functional group, the parent functional group will have the lowest number of carbon. Okay, so make sure that. So right here we have 3 carbons. Okay, in amine, so the name will be propanamine. Propanamine. Okay, so let's go to the next one. Propanamine. Which one that we want to discuss? Let's say we discuss the one that has cyclic. Okay, cyclic. So which one will be number 1? Okay, the priority now, we have 2 functional group. We have amine, amino group, and we have methoxy group. This is called methoxy. Okay, this is amino. Okay, when it becomes the substituent. Okay, but which one will have higher priority? So you may refer to table of group A. Okay, table of group A. Okay, in page 137, you can see that if we have amine, okay, it is included in the priority in group A, but we don't have any methoxy group. Okay, methoxy group, it is not ketone. Okay, it is OR, but it is not ketone. Okay, because it is OCH3. It is not C double bond OCH3. Okay, so it is the ether. ETHER, ether. Okay, so alkoxy is actually in group C. Okay, in page 138. Okay, you can refer. So next. Okay. So how to give name to this? Okay, the amine will be the parent. So this one will be carbon number 1. Okay, so remember, other substituent must also get the lowest number of carbon. So we will start the numbering. We will write the numbering 1, 2, 3, 4, 5, 6. Okay, so we have 6 carbon in the cyclic. Okay, so the parent chain is amine. Okay, amine. So it is cycloamine. Okay, cyclohexanamine. Okay, cyclohexanamine. So methoxy is at carbon number 3. So the name is 3-methoxy. 3-methoxy cyclohexanamine. Okay, 3-methoxy cyclohexanamine. No space between methoxy and cyclohexanamine. Alright. So if we have structure like the one below here, okay, the third structure, which one will be the parent chain? Okay, so you have to count the longest carbon chain. We have CH2, CH3, 2 carbons. We have CH2, CH2, CH3. Okay, so CH2, CH2, CH3, 1, 2, 3 will become the parent chain. Okay, so this will become the parent chain. The name will be propanamine. Okay, so special for substituent for amine. Okay, substituent for amines. Okay, this substituent will not get number if it is attached to N. It will be named or denoted by N. This is the meaning of this. Okay, so how to give name to this? This is ethyl. Okay, so the name will be N. Ethyl. Okay, because the ethyl is attached to N. N-ethyl propanamine. Okay, why propanamine? Because we have 3 carbons in the longest carbon chain. Kita buatlah, habiskan yang ni. Okay, so now we have, obviously this is the parent chain. 1, 2, 3, 4. Okay, butanamine will be the parent chain. Okay, there are 2 ethyl groups attached to N. Okay, these are both ethyl. So how to give name to that? Okay, so we have 2 ethyl at N. So it must be numbered as N. Okay, N dash diethyl butanamine. Okay, so hopefully you get this. Okay, to name the amines. Okay, when we have substituent attached to N. Okay, special for only for amines. Alright. Any question? Dr. Jana, maybe Sir Afif or Madam Ruby? Any questions from the students?
So far, no. No new questions.
Okay, so let's proceed. Now, let's name the alcohol. Okay, alcohol. So, prefix hydroxy. Okay, why, when to use the hydroxy? When the OH becomes substituent. Okay, but in this, for examples, there are all the parent chain. Okay, so it will become suffix all. Okay, for example, here very simple, 1, 2 carbons. Okay, remember to start the numbering from the functional group. So this is ethanol. Okay, next. Okay, now we have we have double bond here. Okay, double bond. Okay, so where to start the numbering? Remember, double bond must get the lowest number. So we give numbering start from here. 1, 2, 3, 4. Okay, OH is at carbon number 3. Okay, OH is still the parent chain because it has the highest priority. C double bond C, okay, does not have any priority. Tak ada dalam group A. So OH will be the parent chain. Okay, parent name. Okay, so the parent name is 4 carbon. Okay, butanol. But we have here double bond. It will be butinol. Butinol. Okay, so how to write that name? Okay, so it will be. Okay, you have to put the. You have to show the numbering. Okay, for the double bond. Okay, so this is actually in. Okay, so what is the name? We have 4 carbons here. So it will be but. Okay, but 4 carbons. Okay, and then we state the position of the OH. Okay, OH is at carbon number 3. But 3. Oh, maybe I give wrong numbering here. Okay, let's kita bagi nama semula. Okay, kita bagi semula numbering. Okay, okay, I will repeat this. Okay, how to give numbering? Okay, remember the functional group must have the lowest number first. Functional group, after that substituent. So this one we consider it as substituent. Called in. Okay, so we have to start the numbering from here. 1, 2, 3, 4. Okay, so how to give name? We have 4 carbons, so it is but. Okay, but. Okay, 3 in. The substituent is in. Double bond, C double bond C. 2 all. And but 3 in, 2 all. Why we do not start from right? Okay, because OH has the highest priority. So it will be it must get the lowest number first. Okay, kita pilih functional group dulu. Okay, to have the lowest number of carbon. Okay, so the name should be good 3 into all. Okay, so another structure. Okay, another structure. Nak buat semua ke? Nampak ke? Okay, let's try. Okay, this one is OH. Okay, OH at carbon number 2, Cl at carbon number 2, we have methyl. Okay, so numbering we start from here. 1, 2, 3, 4, 5, 6, 7. Okay, so 7 carbon in the longest carbon chain. Okay, Cl is the substituent, chloro, so we give name 3-chloro. Substituent, name of the substituent must be in front. 3-chloro, 6-methyl. Okay, 3-chloro, 6-methyl. Okay, and then we state the position of the OH, 3-heptanol. 3-chloro, 6-methyl, 3-heptanol. Okay, last one. And now we have two functional groups, OH and NH2. Okay, so refer back to table of group A, which one will have the highest priority. Okay, if we read the table in page 137, you will see OH is above NH2. Okay, NH2 duduk di bawah. OH, ROH is above RNH2. Okay, so OH will be the parent chain. Okay, so this will be carbon number 1. Parent mesti dapat nombor 1. 2, 3, 4. Okay, so how to give name? So this one, NH2, when it becomes substituent, we call it as amino. Okay, so the name will be 2-amino, 2-amino cyclobutanol. Okay, 2-amino cyclobutanol. So it is understood that the OH is situated at carbon number 1 in this structure. Okay, let's rewrite. 2-amino cyclobutanol. Okay, so that's the name for the last example under alcohol. Alright, so we have time. Ada masa lagi? We have to proceed to the next example. Okay, let's finish this. Okay, how about this one? Ketones. Okay, prefix oxo, suffix on. Okay, not one. On. Okay, oxo when it becomes substituent, suffix when it becomes parent. Okay, so let's give name to the first one. Okay, so the first one, which one is the carbon number 1? Okay, remember parent chain. Okay, parent functional group must get the lowest number. So this must be number 1. 1, 2, 3, 4, 5, 6. Okay, so now the parent is the ketone and not the double bond. But we have double bond in the ring. Okay, so how to give name to this? Okay, so this is cyclohexane if we do not have double bond in the ring. But if we have double bond in the ring, it will be cyclohexene. Okay, so we have to state the position of the double bond, which is at carbon number 3. Okay, so the name of this compound will be cyclohex. Okay, cyclohex. And then we state the position of the double bond, 3-enone. Okay, cyclohex 3-enone. Okay, so very, very unique name. Okay, now let's go to the next example, B. Okay, so we have OH. Ada OH kat sini. Okay, double bond O is here. So which one will have highest priority? Okay, so refer back to table in group A, page 137. Okay, so which one will have highest priority? Is it the OH or the ketone? Of course, the ketone. Okay, ketone will have the highest priority. So numbering start from here. 1, 2, 3, 3, 4. Okay, 4 carbons in the longest carbon chain. So how to name this? Okay, OH is called hydroxy when it becomes a substituent. Okay, so the name will be 3-hydroxy. Okay, 3-hydroxy. And we have 4 carbons. It will be butan. Butan. Okay, position of the double bond O is at carbon number 2. 2-on. Okay, 3-hydroxy butan 2-on. Can you see the name for the compound, Safi? Or Dr. Jana?
Yes.
Yes, clearly.
Yes.
Okay.
3-hydroxy butan 2-on.
Yes.
Dan
Right.
1. On ke on.
Okay, 2-on. Why 2-on? Because double bond O is position is at carbon number 2. Alright, next one. Okay, we have kita bagilah juga ni, susah sikit nak nama ni. Okay, for this one. Okay, we have right here, it's actually CH3. This is CH3, ini pun CH3. Okay, so how many carbon? Okay, how many carbon actually? Okay, we have, okay, let's count. Okay, we have 2 functional groups here. We have double bond O, we have N. Okay, so if we refer to table of group A, okay, table of group A, we can see that NH2 has the lowest priority. So it will not become the parent chain. Okay, so the parent will be the ketone. Okay, parent will be the ketone. So now we start from here. 1, 2, 3, 3, 4, and then this is still carbon. Okay, actually if we write the structure, it should be CH 1, 2, 3, 1, 2, 3, CH2. CH2 kan? Kedua, okay, CH2 there. This is a skeletal structure. Okay, so 1, 2, 3, 4, 5. So there are 5 carbons. Okay, so N has substituent. Okay, and N here is also a substituent. These are the substituent. Okay, N, CH3, CH3, they are substituent. Okay, and actually at N we have 2 substituents, CH3, CH3. Substituent in substituent, how to give name to that? Okay, so let's give the naming. Okay, firstly we have to put the numbering for the position of this one, the biggest substituent here, which is amino group. Okay, so we put 4 dash bracket. Okay, so in the substituent, okay, and here the position is, it is attached to carbon number 4. So we put 4 in front. Okay, and at N we have 2 methyl group. Okay, 2 methyl group. So we put the position as N. Okay, 2 methyl groups. Okay, and N dimethyl. And dimethyl. Okay, and next we also have double bond at carbon number 4. Okay, so very complicated name. Okay, close bracket. Okay, that's the name of the substituent, dimethyl. Oh, belum habis lagi. This is N, amino. So dimethyl amino. Baru kita bracketkan. Okay, let me correct that. So NN dimethyl amino. No space. Yeah, amino. Bracket. Okay, close bracket. We have 5 carbons. It is called pen. Okay, pen. Okay, dash. And then, okay, the position of C double bond C is starting with carbon number 4. Okay, so 4 in. Okay, and then position of double bond O is at carbon number 2. 2 on. Aduhai. Right? Very complicated name. Long and complicated name. But this is what we are going to ask you in the examination. So make sure you know how to give name, okay, to this to the organic compounds. Okay, maybe the last one you can do it by yourself. Okay, that's very simple. Just have to count the longest carbon chain and give the number to the position of C11O. Okay, so if we have aldehyde, and next aldehyde. Okay, so if it becomes the substituent, we can call it as oxo or formyl. Okay, substituent. If it is a parent chain, we call it al. Okay, pentanal, hexanal, and so on. Okay, so an aldehyde can only be at carbon number 1. So the 1 is generally omitted from the name. So we do not put 1 pentanal. We just put it as, we just name it as pentanal. So it's understood that al, C double bond OH is at carbon number 1. Okay, so special case when the chain cannot include in the carbon of CHO, the suffix carbaldehyde is used. Okay, we will see the example. Okay, so example. Alright, so for the next example, okay, let's name. Is this the correct one? Okay. Sama. Same as in your book, but I think the arrangement is different. Okay, so this is actually question D in your book. Okay, question D. So how to give name to this? Okay, we have 3 carbons. Okay, start from here 1, 2, 3. So we do not take the cyclid as the parent chain because the CHO has the highest priority. Okay, so that will be carbon number 1. Okay, always as carbon number 1. 1, 2, 3. So this substituent is cyclohexyl. So the name will be 3-cyclohexyl, 3-cyclohexyl propanal. Okay, so no need to put prop 1-al. Just write it as propanal. Not propanol, propanal. Okay, next. Okay, this is example B in your book. And maybe you can name it by yourself. Okay, maybe we can go to this one. Okay, so this one. Maybe mana satu nak kita nak namakan. Okay, maybe kita namakan yang last sekali lah. Okay, this one is actually example B. Okay. This is B. This is A. Satu kita balik lah. Okay, this one is C. Okay, let's name C. Okay, so this will be carbon number 1, number 2, number 3, number 4, number 5. Okay, so what is the name of this compound? Okay, we have CH2CH3, ethyl. Okay, CH3, methyl. Okay, so the name will be 2-ethyl, 2-ethyl. Okay, 4-methyl. Okay, 5 carbons. Pentanal. So make sure you can differentiate. Propanal 3 carbons. Pentanal is 5 carbons. Okay. So maybe for the other examples, okay, for E and structure B, okay, E and B you can name it by yourself. Okay, let's go to the carboxylic acid. Okay, carboxylic acid. Okay, carboxylic acid can only be on carbon 1, so 1 is generally omitted from the name. So special case when the chain numbering cannot include the carbon of COOH, the suffix carboxylic acid is used. Okay, the example. Okay, so this is E in your book. Let's name the simplest one first. Okay, so this one is carbon number 1 because it is the highest, it has the highest priority. 1, 2, 3, 4, 5. So methyl, 2 methyls at carbon number 2. So the name will be 2,4-dimethyl. Okay, 2,4-dimethyl. Okay, 5 carbons. Pentanoic acid. So it has acid at the end of the name. compulsory to write acid. So after the oic, before acid, you must have space. Alright. So next, okay, maybe we can name the one with the 2COOH. Okay, 2COOH. So where to start? If we start from left or if we start from right, it will be the same numbering. 1, 2, 3. And 1, 2, 3, 4, 3. 4, 5. Okay, now we have 2 COOH in the structure. So how to name this structure? Okay, we have to put the numbering, okay, the position of the of both COOH. Okay, so it is at carbon number 1 and carbon number 5. Okay, so what is the name? Okay, it is dioic. Okay, so pentan, the name, okay, 5 carbons, pentan. Okay, 1, 5. Okay, because we have 2 COOH, the name will be dioic acid. Okay, so this is how we name structure B in your book. Alright, so next, let's go to maybe the one with cyclic. Okay, because it is special. Okay, how to give name? Okay, let's give the numbering first. So it will be 1, 2, 3, 4, 5, 6. Okay, we cannot give numbering like this. Okay, let's say I change the color to blue black. Okay, we cannot give the numbering like this. 1, 2, 3, 4, 5, 6. Why not? Okay, if we give numbering like the blue black numbering, okay, the number of our substituent will be at carbon number 4 and carbon number 6. Okay, but if we give the numbering, okay, like the red one, okay, look at the red one, okay, we will have the position of the substituent at carbon number 2 and carbon number 4. Okay, which one that you have to choose? Okay, just total up the numbers. This one will give us 10. Okay, this one will give us 6. So we choose the lowest number. Okay, so the blue black numbering is wrong. Right. So I will erase that. Okay, tak nak yang ni. So our numbering will follow the red one. Okay. Special for carboxylic acid, the numbering will not start with COOH this time. Okay, because we do not have carbon. Okay, the carbon COOH is actually not included in the cyclic. Okay, cyclic maksudnya gelang. Okay, so dalam gelang, this is the first carbon of the cyclic. Okay, so this is not carbon number 1. Yang the one that I star is not carbon number 1. Okay, so how to give name to this? Okay, this is the special case that I said just now. Okay, so we give the numbering starting alphabetical order. So BR will be first naming. Okay, so it will be 4 bromo. Okay, 4 bromo. 2 methyl. Okay, so what will be the parent chain? It will be cyclohexane. Cyclohexane carboxylic acid. So this is special. Carboxylic acid. And actually you have to continue the name with the carboxylic acid. Okay, maybe I should rewrite. It is actually 4 bromo. 2 methyl. Okay, 2 methyl. Cyclohexane carboxylic acid. Carboxylic and acid has space. Okay. So this is the name of compound. This is actually compound D in your book. Okay, compound D. Okay, so we have 10 minutes. Okay, so let's finish this. Okay, what else? Have derivatives. Okay, derivatives. Okay, salt of carboxylic acid. Okay, the ic acid is replaced by ic. Okay, for example, we name it as ethanoic acid. The salt becomes ethanoate. Okay, sodium ethanoate. Okay, sodium pentanoate. Okay, like that. If it is ester, okay, ester are named as organic salts. That is alkyl come first, followed by the name of carboxylate and ion. Okay. So the alkyl group, we will put the name in front. It will be alkyl, okay, and then alkanoate. Okay, alkyl. Okay, we give the name. We put the alkyl name first. Okay, so if the R is methyl, so methyl. Okay, let's say we have 3 carbons in the alkanoate, so it becomes methyl propanoate. Okay, so it will be alkyl alkanoate. So this is how we give name to the ester. Okay, so let's go to the naming of ester examples. Okay, this one is example 4.12. Okay, so let's say we name the first one, question number 1. Okay, the OH is the substituent called hydroxy. Okay, this is actually carbon, COO, and this is the structure which is actually methyl. Okay, so the structures that we have in practice 4.12 are actually the skeletal structures. Okay, so how to give name to this? Okay, so the substituent, okay, or sorry, the alkyl group is before the oxygen, right here, this one. Okay, so it is methyl. Methyl. So we put the methyl in front. Methyl. And then space. Okay. And then what we have here, okay, this is carbon. Okay, and we have this one. How to name that? Okay, it will be, we have to put the name of this substituent first. So this substituent is at carbon number 1, 2, 3. Okay, it is not counted from below because it will 1, 2, 3, 1, 2, 3, but it will be carbon number 4. Okay, so must have lowest number of carbon, so it will be carbon number 3. So bracket 3 hydroxy. Okay, 3 hydroxy. Okay, and this one, okay, yang ini, this one is cyclopentane. Cyclopentane. Okay, we have 1 carbon here outside the ring. It is not included in the numbering. This is 4, 5. In the cyclopentane. So we call it as carboxylate. Okay. So this is the name of the first structure. Okay, let's go to the next example. Let's say we choose. Okay, let's see we choose this one. Okay, let's see we choose this one, number 3. Okay, number 3. Okay, we have this one is the alkyl group, which is 2 carbons, CH2, CH3. Okay, so it is ethyl. So it will be, this one is carbon number 1, carbon number 2 in the parent chain. Okay, so it will be ethyl. This is the simplest one, ethyl ethanoate. Okay, and maybe the last one. Okay, example number 4 here, because it has a phenyl structure. This is where we use the phenyl. This one is phenyl. Okay, but if we take together with this carbon, it will be benzene. Okay, but I don't want to take that as the together with the phenyl structure, benzene structure. Okay, because I want to give number to that carbon as the longest carbon chain in the ester 1, 2. Okay, so after the oxygen structure, after the oxygen will be the substituent. So this one is cyclohexyl. Okay, so how to give name to this? Okay, we will have name cyclohexyl. Cyclohexyl. Okay, and phenyl is substituted at carbon number 2. So 2-phenyl. 2-phenyl. Okay, 2 carbons in the longest carbon chain. Ethanol. Alright. So maybe last one, a nomenclature of aromatic compounds. Okay, so we have a common parent ring system. Okay, like benzene, if we have only one ring, okay, with 3 double bonds, we can have naphthalene, we can have anthracene. Okay, but normally in our syllabus, we will just ask you about benzene. Alright. Okay, if we have one substituent, you just have to give name as chlorobenzene. No need to put one chlorobenzene because it is understood that there is only one Cl there. Okay, so chlorobenzene. Okay, nitrobenzene. Okay, this is nitro. Okay, this is chloro, nitro, and this is 2 carbons. Ethylbenzene. Okay, that one is mono substituted. Okay, only one substituent. Okay, in the benzene ring. If we have a compound like this, okay, the substituent is it is the one of the group of the highest priority. So this is the decreasing priority. So carboxylic acid still have the highest priority in naming. So if we have COOH bonded to the benzene ring, we call it as benzoic acid. Okay, the special name. SO3H bonded to benzene ring, benzene sulfonic acid. Okay, and H2 bonded to benzene ring, we call it as aniline. Okay, CHO here is actually C double bond OH. Okay, which is an aldehyde, so benzaldehyde. Okay, phenol. Okay, phenol. Okay, this is not phenyl. Phenyl without OH, without CH2. Okay, as substituent. But this time it all structure becomes the parent. So we call it as phenol. Okay, it is part of alcohol. And this one is called toluene, or another name is methylbenzene. Okay, maybe for this one, disubstituted benzene. Okay, so there are only 3 possibilities, whether it is ortho, meta, or para. So this one is if we have 2 substituents bonded to the benzene ring. Okay, so if we have 2, okay, at carbon number 1 and carbon number 2, we call the name as ortho, or sometimes we put O in front of the name. Okay, 1 and 3. Okay, carbon number 1 and carbon number 3 has substituent, we call it meta or M. Okay, para is 1, 2, 3, 4. 1 and 4. So we call it para, or we just put P in front of the name. Okay, so this is the example. Okay, so let's give the name. This is 1, 2, 3, 4, 5, 6. Okay, so we have 6 carbon. This is benzene. Okay, so substituent is at carbon number 4. So how to name this? Okay, it is 1,4-dibromobenzene. Okay, or you can just name it as P para 1,4-dibromobenzene. Okay, so for this one, COOH will have the highest priority. Okay, so it will be benzoic acid parent chain. Okay, so this one is the substituent at carbon number 3. So the name will be 3-amino. Okay, 3-amino benzoic acid. Okay, so maybe kita habiskan lah. Okay, this one is methoxy. Okay, and then this one, okay, is actually C double bond O. Yang ini ada H. Okay, so it is a benzaldehyde. So this is a benzaldehyde. Okay, so how to name this? Okay, how to name this? Sorry, another name for the second example here. Okay, benzoic acid. We can also name it as it because this is 1,3. Okay, substituent at the benzene ring. We can name it as M-amino benzoic acid. So both names are acceptable. Okay, so for this one, 1, 2. Okay, so it will be 2-methoxy. Okay, 2-methoxy benzaldehyde. Or, okay, if 2-ortho. O-methoxy benzaldehyde. Last one, okay, these are all the parent chain name called phenol, and this is actually methyl. Okay, so we can name it as 1, 2, 3, M-methyl phenol, or you can also name it as 3-methyl phenol. Okay, I think this is the last slide. Okay, polysubstituted benzene. Polysubstituted meaning we have more than 2 substituents. Okay, so how to give name? Just as usual, make sure you identify which one is the parent chain. This time we have aniline. Okay, aniline as the parent chain. Okay, and this is a CH3 that bonded to N. Okay, so how to give name? Okay, it will be, okay, let's give the numbering first. 1, 2, 3, 4, 5, 6. So it will be 3,4 dichloro. Okay, and then we give the name for the substituent attached to N, N-methyl, N-methyl aniline. Okay, and the last one. Okay, so which one will be the number? So let's say I want to take this, all this as the parent chain. So the parent chain is toluene. Okay, toluene. So how to give name? So this is carbon number 1, number 2, number 3, number 4, 5, and 6. We have 3 bromo there. So it will be 2, 4, 6. Tribromo toluene. Toluene. Okay, the wrong spelling there. Okay, it should be toluene. Toluene. Okay. This is T. Alright. So I think that one is the last slide from me. Any question? We have exceeded the time about 10 minutes. Safif. I have finished all the discussion.
Okay. Thank you, Miss. There is a question here. How many marks will it take in exam to name a compound based on IUPAC nomenclature?
How many marks?
How many marks?
Very good question. Okay, you can see that just now we have given name to a lot of compounds and most of them have a long names, right? Sadly to announce there will be only 1 mark for the naming. Okay. There will be only 1 mark for the IUPAC nomenclature, and this is actually C1 question. Okay, C1 means it is just the lowest level, okay, which is remembering. Okay, so C1 is the easiest question in the examination actually. Okay, so the mark for the naming is only 1 mark for 1 name. Okay, any other question, Dr. Jana?
Alright, the last one. When do we need to put bracket in naming?
When do you need to put bracket in naming? Okay, when to put bracket in naming? Okay, usually we put bracket when we have substituent in substituent. Okay, for example, tadi kita dah bagi name. Let me show you. Substituent in substituent. Okay, for example, there's this one. Okay, the substituent of the carboxylate. Okay, this is the carboxylate. Okay, C here. Okay, only one carbon. That's why we call it as carboxylate. Okay, there is substituent at the carboxylate. Okay, which is this one. So in this substituent, we have another substituent. So actually, if in the class, I usually say like this. Okay, dia ada anak. Substituent is like the son of the parent. Okay, anak dia lah. Okay, ini anak dia. Dan anak dia ada anak pula. Cucu dia lah. Cucu kepada carboxylate ni. Okay, that's why we have to put bracket. Okay, so we put the name of the cucu first. Kita namakan cucu dia dulu. What is the name of the cucu? Hydroxy. Okay, so 3-hydroxy. Okay, and then nama anak dia cyclopentane. Nama bapa dia, parent dia di belakang. Atuk dia dekat belakang. Okay, so like we write our name. Okay, we write our name first. And then our parents' name. Nama ayah kita kan. Okay, so nama kita, kemudian nama ayah kita. Okay, tapi kalau kita ada anak nanti, so anak, contoh anak saya, nama anak saya, nama ayah dia, nama atuk dia. So it will be like that. Okay, so that is when you have to put bracket. So when we have substituent in substituent. Okay, I answer your question, Dr. Jana. The student's question, boleh ke?
Yeah, that's all questions from the students.
Okay.
Okay.
Okay, attendance link I will give. Okay, I will share my screen right now.
Alright.
Okay. Where is it? Where is it? Aduh. Windows.
Maybe I have to stop sharing first.
Try. Okay, wait. Okay, I have to edit a bit. Yeah, good. And then this one copy. Copy image. Okay. So, organic shop. Okay. Okay. So, can you see? You can scan or you can type the website link. Okay. Fill the details and answer a question. I believe that I have set up a question. Okay, so since almost 6:15 already, Madam Latipah. Okay, thank you to Madam Latipah for giving a talk this evening.
Hi, you're welcome.
Do not worry, we have record this. Okay, we have record this workshop. Okay, and I will post it in YouTube once the link is ready. Okay. So yes, kita nak solat asar lagi dah pukul 6 suku So kita end our organic pre-organic workshop actually. Okay. So ada apa nak cakap lagi, Madam Ruby? Madam Ruby nak cakap ke tu? Madam Ruby? Yes.
Rakaman yang tahun lepas pun kita release jugalah. Can we do that? Dengar tak?
Yes. Link tahun lepas. Last year.
Boleh.
Yang after talk tu.
Okay.
Sebab yang ini banyak sangat lag. Takut masa terrecord pun lag juga.
Yes, of course lah, dia akan lagging jugalah tu.
So Seafif punya tahun lepas continuous, cantik, tapi 3 jam ya students, 3 jam.
3 jam. And then saya jangan skip ad kalau ada ad tu jangan skip ad. Nanti duit tak masuk. Okay? Okay, jangan skip ad later I will give the link ni waktu petang-petang ni dah nak soal asal lagi anak-anak lagi ni yang dah berkahwin ni macam itulah. Okay, so I believe that all of you have okay fill the attendance, so we end our live session with tasbih Farah and surah Al-Asr. Okay, that is all from us. Okay, hopefully, okay, we can achieve about 500 attendance. Okay, 500 or 600, and okay, see you guys. Okay, on lecture next week. Okay, thank you class. Oh, thank you class. Macam lecture dah. Okay, stay safe guys. Assalamualaikum warahmatullahi wabarakatuh.